Hi, welcome to Expanse Tension Theory Solving Science, episode number 3. I really like this one because we're solving two different problems in one. So let's get straight into it. Dying star defies explanation. A red supergiant is surrounded by a puzzlingly large bubble of dust and gas, as reported by New Scientist magazine, 2nd of August 2025 on page 8. Now there's a second problem. As well as this huge interstellar medium of dust and gas, which has propelled itself out to 50,000 times the width of the distance of Earth's sun. So this thing is enormous. Okay. One, science cannot explain how within 4,000 years since this super red giant exploded out of its sun, how this gas has been propelled at 30 meters per second over all that time, such massive distances. The second problem is there appears to be a line or a shell or a density change somewhere along the radius of the size of this star. Now, general relativity and anything else would only predict a smooth transition from dense to low density, a smooth curve of density transition. But we're not seeing that. We're seeing some form of inner shell, inner line of density gradient. Okay, so let's try and unpick it. Can expanse tension theory explain it? Yeah, of course it can. So firstly, the dense inner core of this star exists in a regime as Newton and Einstein would approve of. We've got the normal standard model forces of nature holding mass together, and mass is uncoupled from expansion of the universe. And in that regime, mass holds itself together. But as the transition through the radius of this huge star goes to low density, ETT predicts a coupling of mass to the underlying expansion of the universe. That would give that interstellar medium, this gas and dust, an additional accelerated driving force and drive it out further at faster rates than would have otherwise been possible with general relativity. So yes, we can explain how this red supergiant has got so massive. Secondly, this shell, along a path of radius of the star, indicates maybe a halfway point. There's some density modulation, a line, a shell evidence. Well, what could be that? Or what could that be there? Well, again, at the point of the termination of high density space where matter is held together tightly, transitioning sharply into a low density regime, you would see a sharp cutoff and transition. You would see a gradient as predicted by expanse tension theory. Now again, no other theory can explain how along the radius of this star you see a density gradient change as sharp and precise and something we can detect. Final point, is DFK 52 unusual in any way, shape or form? Expanse tension theory says not, that any red supergiant could do this. We possibly haven't seen many of them, but within expanse tension theory, the size and shape of this dust bubble and cloud bubble could be normal. The inner shell gradient within the radius could be normal. And I'd suggest there's an implication for the Earth, because one day our own sun is going to go red supergiant, and current general relativity given predictions say how far that cloud and bubble will progress. If expanse tension theory is correct, I'd get to the bunker. Okay, so this is fun. Thank you for watching. Thank you for subscribing. Thank you for sharing with friends. We're trying to uncover the true underlying cause of the universe. And thank you for watching. Okay, bye-bye.